Okay, good morning students. Today in chemistry we discuss about spectra. Okay, emission and absorption spectra. This spectra is nothing but is the emission of light from atom. That's why it is known as atomic spectra. Simple thing is when a ray of light, means white light, ordinary light, is passed through the prism, the wave with shorter wavelength bends more. Wave with shorter wavelength bends more as compared to the longer wavelength. This spreading of light is known as spectra. Spreading of light. These are also known as line spectra. Why? Because different dark and light patches or lines are observed. That's why it is known as band spectra or line spectra. As for example, visible light, when it passes through the prism, it is converted into 7 colors, Vibgyor, having different wavelength, from violet to red. This violet means the small wavelength, so it will bend more. So bending of violet light is more as compared to red light. Red light means larger wavelength, so it's bend less. That's why red light is used in stop signal in traffic. So in traffic, red color is used for stop. Why? Because its bending is less and it travel more distance. Okay. Second thing that we discuss today is emission and absorption spectra. And third, last one, we discuss about hydrogen spectra. Emission and absorption spectra. Emission spectra. When light fall on particular atom or electron, it absorb energy from the light and try to rotate. So it absorb light of particular frequency. That is known as absorption spectra. Again that electron again come back to its normal position or normal speed by emission of light. That is known as emission spectra. So we will discuss about absorption spectra and emission spectra, how this energy is related with the wave number that we will discuss, and in the end we discuss the hydrogen spectrum, where different series. Hydrogen spectrum is observed by filling gas of hydrogen in a discharge tube, and then electric potential is applied, then different light bands are observed that we study in hydrogen spectrum. Okay, second topic is about emission and absorption spectra. The branch of science in which this absorption and emission spectra is studied. Okay, that is spectra means the light. That is known as spectroscopy. Radiation is passed to the sample. So if light of particular wavelength is passed to the sample, which absorb radiation of certain wavelength, and remaining is passed through. The missing wavelength is the radiation absorbed by the metal. It gives dark patches. This space of bright light, that is known as continuous spectra. Emission spectra of atom is gaseous phase, shows only one type of emitted light of specific wavelength. So that is nothing but emission spectra. So in emission spectra, wavelength remain same and dark patches are observed. Okay, black band are observed. Then it is known as emission spectra of one wavelength, nearly same. But if wavelength is of different type, as for example Vibgyor, then that is absorption spectra. So two type of spectra we can absorb, emission spectra and absorption spectra. Again I revise, absorption spectra, particular light is absorbed, so it gives black light. Suppose we pass different colors of light from it and pass to the sample, then sample absorb green light, then output detector will not detect green light. That is known as absorption spectra. Emission spectra, visible light, when passed to the sample, it is converted into different wavelength of light, that is Vibgyor light. That is known as absorption spectra. Okay. emission spectra and absorption. Third topic related with this spectra, that is we discuss hydrogen spectrum. Okay, hydrogen spectrum. Okay, third topic of this spectrum is hydrogen spectrum. Okay, line spectra of hydrogen known as hydrogen spectrum. When an electric discharge is passed through hydrogen gas, as previously we have studied hydrogen gas tube or discharge tube, hydrogen molecules get excited and produce energetic radiation having particular frequency, that is known as hydrogen spectra. Okay, it's get excited when electrons are revolving around the hydrogen atom. When light fall on it, then sufficient energy is absorbed by that particular electron and goes to excited state. When it comes down to its normal condition, then it's emit radiation, that is known as emission spectra. It depend upon different orbital. In hydrogen, outside there are different orbital 1, 2, 3, 4 onwards. Different stages are there of the electron. From that, again, when this electron comes down, it emits radiation of particular wavelength. If this distance of orbital, first orbital, second orbital, third orbital, fourth, if it's dropped from infinity to ground state, means n is equal to 1, then energy emitted is having very high energy. So that we will study in this hydrogen spectrum. This hydrogen spectrum, the energy which is emitted is directly proportional to N1 and N2, means from which orbital it is emitted. And another number is given, that is 109677. That is known as Reisenberg constant. So it is directly proportional to its wave number. Okay, V bar. The energy which is emitted is directly proportional to wave number. Wave number we know 1 by lambda. Number of waves passes through a particular point. 1 by lambda, that is equal to wave number, is equal to 109677 into 1 upon n1 square minus 1 upon n2 square. Instead of n1 and n2, we can write ni square, means initial, and n2 you write nf, means final state, centimeter inverse. Why? Because it is 1 by lambda. Where n1 is equal to 1, 2, 3, 4 onwards, it is an integer, but it is nothing but the orbitals. And n2 is equal to 2, 3, 4 onwards, okay, orbital. And this is the Reisenberg constant. So different types of spectra are observed. We gave the number when electron from excited state, okay, from higher state 2, 3, 4 onwards, it comes back to one position. Then that spectra is known as Lyman spectra. Okay, Lyman spectra, scientist name is given. And this comes under ultraviolet region. Its wavelength is very small. Why? Because from higher energetic orbital it comes down to ground state. So energy wavelength is less, you can see, and energy is more. Second, when it drops to second state, n is equal to 2. Here n1 it is equal to 2 and here it is 3, 4, 5 onwards. Then it comes to the visible region, and that series is known as Bellman series. So 5 series are observed: Lyman, Delmer, Peston, Brackett and Furr, where Ni is equal to 1, 2, 3, 4 and 5 respectively. N2 means Nf is one step or more than one step higher. So if it is 1, then it is 2, 3, it is emitted or dropped back to 1. 3, 4, it dropped back to 2. And third one, that is Peston, then 4, 5, 6. This Belmer series, then we have visible region. So Belmer series, we have visible region, and Ni, that is N1 is equal to 2 and Nf may be 3, 4, 5, 6 onwards. Visible region means with your color. Visible color can be observed with our eyes. Second, IR region means Peston, Brackett and Furr. its energy is very very less. So it wavelength you can see it is large, more wavelength, higher regions. So this is all coming in infrared region. So this is all about hydrogen spectrum. From the spectra we can find this series it is. So you remember Lehman, Belmer, Teschen, Brackett and Fun. Series starts from 1, 2, 3, 4. This is what ground state and this is the excited state. The distance between this 1 and 2 is very very high. Or distance between n is equal to 1 and n is equal to 2 is high. That's why ultraviolet region is there. Okay, wavelength is small, energy is high. Other this region, infrared, the distance between these 3, 4 and 5 orbitals are very very less. That's why energy difference or emission spectra coming in infrared region. Okay. One table is also there in your textbook. You try to draw it. This equation is made. Wave number, remember wave number 1 by lambda is equal to this Reisenberg constant value 109677 into 1 upon Ni square minus 1 upon Nf square centimeter units. From that we can find the wave number, and from wave number we can find the wavelength, and from wavelength we can find the energy of that particular electron. E is equal to energy, E is equal to h mu, mu is equal to c by lambda, E is equal to h c by lambda. Lambda if you know, c is constant, h is constant, so we can find the energy of electron which drop back, or emission spectra energy also you can calculate. Okay, thank you.